Okay, so we're starting acids and bases, so that's your heading. Okay, now you guys did acids and bases in grade 9, right? So a little bit of the stuff should be familiar to you. Okay, just general properties of acids. Katela? They taste sour. Okay, if they're safe enough to eat, they taste sour. What are some common acids that we get in real life? Not so much. Vinegar, there's this type of acid in vinegar. You know what that acid is called? Ethanoic acid. Well done. Ascorbic acid. Where do you find that?
In citrus.
Is it ascorbic acid? I think that's citric acid.
That's vitamin C.
Vitamin C is ascorbic acid. Okay, well done. What else? What other properties of acids are there? They taste sour if they're safe to taste. They're corrosive. Okay, if they're strong, they can be corrosive. Okay, their pH is what? Where does their pH lie? Okay, so let's look at your pH scale for a second. Yeah, so we've got a pH scale from 0 to 14. 7 would be neutral. 14 would be basic. And 0 would be very acidic. If you dissolve a base in water, what do you call it? There's a different word that we use. Alkaline. Yes, nice. Alkaline. Okay, so alkaline. What do we call the group 1 and 2 metals again? Why is that? But why alkaline? Why alkaline? They're basic. They form basic solutions. Okay, so the pH we said is below 7. What do all acids contain? Or when they break up in water, all acids give off or form something specific. Let's say, can you think? So what are some of the lab acids you guys spoke about last year? Did you speak about it? Sulfuric acid, hydrochloric acid, nitric acid? Not really. Okay, they all contain hydrogen ions. Okay, that's the property of an acid. Did you do that? Cool. I'll open one more window at the back. Sorry, we just need to make sure there's a breeze going through here. Okay, so let's see. Some of these are a bit not as important, but we can write them down. When you dilute an acid, okay, let's say in the lab you're doing an experiment, and we obviously don't want you to work with a very strong acid and burn yourself. How do you dilute it? Do you always add the acid to the water or the water to the acid? Yes. Okay, you add the acid to the water. This is a random side note, but there's a reason I'm talking about this. You always add acid to the water. Why? They have very exothermic reactions when you dissolve them in water. So you can write that the temperature rises when diluted in water. And then you can draw a little picture for yourself. No one is preventing them from asking that. Whenever you dilute it, you always add the acid to the water. You basically want as little acid at any time. So if you have a beaker of acid and you add water to it, you can imagine that's dangerous. That's a lot of acid. Whereas if you add the acid to the water, little by little, that's very little acid and a lot of water. So it's not as dangerous. You don't want to add the water to the acid, have it be exothermic and splash out and burn you. Okay, so the temperature rises. That's called an exothermic reaction. Did you guys talk about exo and endo last year? Okay, it doesn't really sound like that. Okay, so the temperature rises when acids are diluted in water, which indicates that it's an exothermic reaction, so it's something that gets hot. Okay, we said they taste sour if it's safe to taste. We spoke about the hydrogen ions. Okay. Then let's write down some common acids. Okay, so these are called your lab acids. Okay, so this was the exothermic thing you guys wrote down, so don't you write down from the board. Okay, so what you call lab acids. So these are your very strong acids. Okay, I mentioned them earlier. What did I say? There's sulfuric acid. What's the formula for sulfuric acid? H2SO4. They're also on that list, I think at the beginning of the year when we made a list of compound ions. I think we added them to the list of things we need to know the names of. Okay, H2SO4 is called sulfuric acid. Okay, what else? What are common lab acids?
Phosphorus.
Phosphoric acid is not such a strong one, but that's a good one. I'll add that one to weak acids. What are other strong ones? Hydrochloric acid. Where do we find hydrochloric acid? Stomach acid. Yeah, it's a very strong acid. Pool acid would also be hydrochloric acid. Okay. Pool acid.
It's not very strong because that's one of the acids I've been testing.
Are you talking strong in the sense of what?
Like, like it's corrosive.
So is it not very diluted, the ones that you're using?
No, it's not diluted at all. I'm
Ooh.
just using full acid.
Well, no, then it must be diluted. Because if you took proper, strong concentrated hydrochloric acid, it's very dangerous.
Oh.
I made the mistake one year of literally like there was a beaker somewhere and I did whatever I tell my students not to do and I thought it was water and I took a whiff of it and it like pretty much burnt like yeah, it's very strong.
Very strong.
Yeah. What's the other strong acid? Nitric acid. Okay, so these are your lab acids. They're very strong acids. Okay, we'll talk about what strong acids mean exactly, but for now we'll just write them down. Okay, so those are very strong acids. So those are the three in the lab that we'll use when we do like experiments and we need a strong acid. Then let's write down some examples of weak acids. Okay, so Chloe mentioned phosphoric acid. You can write that one down. H3PO4. Just write the heading weak acids though, hey? These are not strong. Weak acids, we have phosphoric acid. Sorry, I don't want to show you the other one yet. Carbonic acid is another one. Where do you find carbonic acid? If you drink a lot of something, you'll have a lot of carbonic acid in it. Yeah, like fizzy drinks have carbonic acid because you're basically dissolving CO2 gas in them and it forms carbonic acid. So that's the other one you can write down. Okay, and make a little note there for yourself of where you find it. It's interesting. Oh, phosphoric acid is also oftentimes added to fizzy drinks. Okay, to give it like a certain flavor. You guys mentioned acetic acid or ethanoic acid that has two different names. Okay, like a common name and then a proper organic chemistry name. So acetic acid, that's CH3COOH. We've learned the compound ion, isn't it? That acetate ion, CH3COO minus. Okay, and oxalic acid, COOH. We also, no, I don't think we've gone into that one too much. Okay, so there's 4 weak acids that we need to know in case they ask us. Okay, then let's write down what strong acids are, or what makes something a strong acid. Everyone done with the list? Okay.
Yeah, it just came down.
Say again?
It just came down.
Okay, let's see. Okay, so let's write the definition of a strong acid. What do you guys think the definition of a strong acid is? If I said to you like something is a strong acid, what would you say? What does that mean? It's corrosive, it's pH, what do you think? Okay, so say again? Low pH has got to do with that. Okay, so the proper definition is strong acids, here we go, ionized completely in water to give a high hydronium concentration. I'll explain that to you, so don't stress. So strong acids ionized completely in water to give a high hydronium concentration up here. Okay, strong acids ionize completely in water to give a high hydronium concentration, but we need to explain what that means because that doesn't really mean much at the moment. What does it mean if something ionizes? Or what are ions? Positive or negatively charged atoms. Atoms that have lost or gained electrons, right? Those are ions. So when it says strong acids ionize completely in water to give a high, forget about that hydronium concentration, we'll get to that. But let's talk about the ionizing for a second. Okay, so we've got, let's say strong acid is HCl. Now it says in water, so that's plus water there. Okay, so it says it ionizes completely in water. Now I think just listen to me first and then write down, because I'm going to write it wrong first and then I'm going to fix it. Okay, so HCl is a strong acid that ionizes completely in water. What do you think HCl breaks up into when it breaks in water? What do you think it forms? H plus and Cl minus. Okay, HCl when it breaks up forms H plus and Cl minus. Okay, again, don't write this yet because I'm going to make a little bit of a mistake first. Okay, and then obviously the water is still there. Okay, so I'm going to say plus water. Okay, now that H doesn't want to be by itself. Okay, immediately it doesn't want to be by itself. It's unstable. It's not happy. So it joins with the water. And what do you think it forms when it joins with the water? H3O plus. That's it. Okay, so what I wrote at the top is actually not the way you're going to write it in a test. You're going to write it forms H3O plus. What is that called again? It's a type of compound ion. Hydronium ion. Well done. It's called a hydronium ion, and it forms that. So actually what you guys would write in a test or something is you would write, let me just erase this, HCl plus water gives me H3O plus and Cl minus. If you want to write this top line first to show yourself how the hydronium formed, you're welcome to do that for now, but in a test you won't do that. Cool, you guys can write that down. Okay, so strong acids ionize completely in water. We'll draw a little picture of what they mean by the completely. Okay, so it breaks up in water, in other words. Okay, and remember the definition? It says it ionizes completely in water to give a high concentration of hydronium ions. There we go. There's our hydronium ions. Okay, what does that mean? When you dissolve HCl in water, when strong acids in general are dissolved in water, they desperately want to break up into their constituent ions. They don't want to stay H bonded to Cl. They want to break up. So if you had a beaker of HCl dissolved in water, what you would see is, if you could physically see the molecules, you would see a lot of H3O plus ions, a lot of Cl ions, but you wouldn't see any HCl molecules. Why? What does the HCl molecule want to do? Break up. And when it breaks up, the H forms with the bonds with the water and forms hydronium, and the Cl is just happy by itself. Okay, so this is what you'll see with a strong acid. You'll see that it breaks up completely. Now, I'm actually going to do something. I'm going to change this arrow a little bit, or let's change the second one that's actually correct. Okay, so a lot of reactions in real life are reversible. So a lot of reactions should actually be drawn as double arrows like that. For example, I could take water that's like solid ice and I can melt it and it can become liquid. And is that a reversible reaction? Can I freeze that water again and become solid? That's reversible, right? So I should actually make this arrow a double arrow. This is a reversible reaction. Now what I mean by that is the HCl can break up and form H and Cl, and then that HCl can bond